So very good evening, friends. So today, we are having the third session on this answer writing, geography answer writing. Now, again today I have just taken somewhere around 8 questions for the practice purpose, and most of this question I have just taken the relevance from the current events in the sense last 1 year, whatever has happened. Somewhere I have just taken the clue from that, and accordingly, say for example, I have just selected the questions as such. Okay, right. And one more thing, today's this answer writing practice, I have concentrated on only, say for example, uh, the two topics of the syllabus. One, the salient features of world physical geography and the important geophysical phenomena such as earthquake, tsunami, volcanic activity, cyclones, etc. Only the two topics I have just taken the questions from. Okay. So having said that, we'll just say, for example, directly jump into the discussion, right? The very first question, I've just taken this bomb cyclone as a concept. See, why exactly I've just taken? Because the end of the year 2022, almost the December, month of December last, uh, we had, say, for example, you would have heard something called as blizzards, right? Normally, this polar outbreaks, the Canadian polar outbreak, you call them as what? Blizzard. And very intense. Say, for example, this blizzard was considered to be the most intense blizzard in the last decade. And complete Niagara Falls has frozen, right? And occasionally, right, once in a while, this Niagara Falls will be frozen, right? And that's the reason I have just taken one concept that is associated with blizzards, and we call them as what? Bomb cyclone. Two things are there. One, the term is also sometimes fanciful, right? Right, attractive, and sometimes it is also there in news. If that is the, say for example, is the term that we come across, I always believe that if it has a relevance with the syllabus, it's very, very important. Okay, so the very first question, okay, I have not mentioned the word limit. Only thing is that, as I said, if at all, if it is asked for 10 marker or for 15 marker, what I should do, somewhere I know 10 markers I have to write 1.5 pages. 15 marker, I have to write 2.5 pages. Or you can say 150 words and 250 words. Correct? Correct. So slightly, say for example, I have added more informations to the answer, but some of the key aspects that should be there. Okay. So read the question. If I just start reading the question, what exactly the question says? Question has two parts. Number one, what is bomb cyclone? They are asking explicitly. It means I have to define or say, for example, briefly explain. Explain means very say for example, right, uh, in a systematic, in a detailed fashion I should write it. Briefly explain means, right, say actually speaking, the word briefly explain is an oxymoron, but somewhere I can write it, right? I can write something about this bomb cycle. Then the second question, they say describe the conditions required for the formation of the, right, of one. It means of one in the sense formation of bomb cyclone. So number one, what is bomb cyclone? Somewhere we should define it, slightly elaborate on the same. Then I should talk about the condition required for the formation of the bomb. If at all of this question is asked, I confident that they may be asked only in what? 10 marker question as such. So what is a bomb cyclone? I'll tell you. See, somewhere condition, if you ask me, bomb cyclone results in, say for example, blizzard like condition. Okay, right. Now a bomb cyclone is simply a storm that intensifies very rapidly, right? So bomb cyclones normally forms when the air near the Earth's surface rises quickly in the atmosphere, triggering a sudden drop in the barometric pressure. So if you ask me what exactly is the definition, the last sentence is very important. The last sentence, it says what it says. This is what the definition is all. Okay. Now see, for example, how a low pressure is created. If you ask me how a low pressure is created, wherever I have this rising convection is very strong, wherever the air mass rises very rapidly and quickly, say for example, the pressure at the surface will drop. That's what this, say for example, the definition talks about. But whatever be the case, if you ask me, right, what exactly is the crux? What is the crux if you ask me? It is all about at least the pressure should drop 24 millibars within 24 hours. It means one day the pressure should drop at least for 24 millibars. Okay. If such is the sudden drop in the pressure, you call this situation as what? Bomb cycle. And let me tell you, my dear friends, suddenly a low pressure will be created. That's what you call them as what? Bomb cycle. And bomb cyclone, my dear friends, normally it is very, very, say, for example, common in winters. And now you may wonder, what is this winter? It is so common. I'll tell you, winter it is common in the sense because, see, for example, wind always comes from high pressure and it will be moving towards what? Low pressure. Okay. I'll put it this way, right? For example, when exactly bomb sink, I should understand that any pressure system is or the movement of air mass is three-dimensional. For example, if I have a high pressure at somewhere, assume that, okay, I'm there in the polar regions, very cold condition, high pressure, right? Somewhere around 60-degree latitude, right? I'll call it as what? Subpolar low. I'll be having a low pressure. Okay. I know wind always moves from high pressure to low pressure, but I should also understand that whenever I just talk about, say, for example, any low pressure, how exactly low pressure is created, if you ask me? Low pressure is always created by what? Rising air mass. High pressure is always created by what? Subsiding air mass. If that is the case, above high pressure, always at tropopause level, I'll be having a low pressure. Above low pressure, at tropopause level, always I'll be having what? High pressure. And there also I'll be having a movement, right? In tropospheric level or tropopause level, from a high pressure to low pressure, that air mass will be moving. Very popularly, we call them as what? Geostrophic winds. We call them as what? Jet streams. It goes by many names. Okay. Now, the wind is there both at the surface level and upper air surface. Now, see, my dear friends, there is always a link, right? This low pressure can also be created, right, because of the rapid rise, say, for example, of these air mass, or say, for example, the low pressure can also be intensified by this high pressure which is created. Because I understand it is a cyclic. Am I right? If the high pressure get intensified, again I understand, say for example, it has an indirect effect where exactly the air mass will also rise at what? A rapid pace. When I talk about winter, my dear friends, polar region becomes very intensified high pressure, right? Very intensified high pressure. And of course, I understand from the polar height, somewhere around 90-degree, right? Not necessarily it is 90-degree for understanding purpose. From 90-degree to somewhere around 60-degree latitude, my difference. Normally what happens? I'll be having a wind which will be flowing, and very popularly you call them as what? Polar wind. Okay. Normally what happens? Winters, this high pressure, polar high pressure, right, becomes very, very large in its size. So it will be going for an outbreak. One such outbreak, we call them as what? Blizzards. Okay. So bomb cyclone and blizzards, they are very somewhere very much correlated. Conditions and all, if you take it, right, it is more or less similar. Okay. Okay. Whatever be the case, if you ask me what exactly is a definition I can take it. If at all, if I have a rapid fall in the pressure, how rapid? At least 25 millibars within 24 hours. The situation, we call them as what? Bomb cyclone. Okay. Now talking about the rapid, so okay, describe the condition required for the formation of the one. What is the condition required? Deep tropospheric frontogenesis process. See, and talk about this frontogenesis process is the one which happens along this subpolar low. Sometimes very popularly you call them as what? Mid latitudes. Okay. Somewhere around the 60-degree latitude, not necessarily 60-degree latitude. Winters, every pressure belt will be shifting south. Am I right? So during winters, this process of frontogenesis can also happen somewhere around 50-degree or 40-degree, right? Because I understand every pressure belt will be shifting south. I'm talking about winters of northern hemisphere, okay, which occurs both during upstream and downstream of the cyclone, right? Surface. Influence of air and sea interaction. Technically, if you ask me, when I say influence of air and sea interaction in the sense, I'll put it this way. A wind normally, say for example, if I take this frontogenesis, my dear friends, front is a very important climatic phenomenon. Temperature inversion, temperate cyclones, right? Even say, for example, frontal precipitation, taiga type of a forest formation, right? Boreal forest, right? Frontogenesis. Every atmospheric condition you take it, the concept associated is a front. What is a front, if you ask me? Front is more like a boundary of an air mass. Say, for example, 60-degree latitude. If I just take the 60-degree latitude, my dear friends, 60, assuming, see, I'm just taking it, assuming that I'm not taking the entire concept because I assume that basic knowledge you have already. Okay. This is a place where I have a low pressure called the subpolar. This is a place where I'll be having two wind that is merging with each other. Maybe I'll use different colors. Okay. One, a wind which is coming from polar high, and a wind which is coming from what? Subtropical high. The wind which comes from subtropical high, horse latitude, Very popularly, we call them as what? Westerly. We call them as what? Westerly. A wind which comes from the polar region, you call them as what? Polar winds, or you call them as what? Polar easterly. Okay. Two contrasting air mass. When these two contrasting air mass tries to confluence with each other, they are so contrasting in nature, they do not readily confluence with each other. It forms a clear-cut boundary between them. That boundary is what you call them as what? Front. Technically speaking, this polar wind, if you ask me, what will be the nature if you ask me? Normally, we say it is more like, say, for example, right? It is more like CP. C means continental, P means polar. So, continental wind will be dry, polar wind will be cold. So, for example, this wind will be cold and dry winds, my dear friends. Whereas, when I talk about westerly, normally westerly wind will be empty. Empty means maritime tropical. Maritime means wet, and tropical means warm. This wind will be warm and, say, for example, warm and wet. See the contrasting nature. One is wet, one is dry. One is cold, one is warm. Okay. Normally, when I talk about, say, for example, sea, somewhere I am just talking about this empty as an air mass, maritime tropical. Indirectly, I am talking about the westerly wind, influence of this westerly wind. Okay. So, when two contrasting air mass tries to confluence with each other, my dear friends, that's a place occasionally you will be having the development of what? Squall line. Squall line is also a technical word. A quasi-linear system of convective system which is known for bad weather effectivity, you call them as what? Squall line. Okay, you call them as squall line. See, when I say bad weather, all that strikes your mind when it comes to bad weather, you can take it as squall. That's a, say, for example, phenomena. It will be associated with what? Squall line. What all bad weather phenomena I can have? I can have lightning. I can have thunder. I can have cumulonimbus clouds, very dark cloud. I can have, say, for example, hailstorm. I can have cloud burst. So many things. Okay, right. Right, my dear friend. So, somewhere if you take this condition required for the formation, you can say frontogenesis process to keep things very simple, right? Instead of avoiding the technical words, what you can say, right? Say, for example, almost having the frontogenesis process or creation of a front. Okay. Then I can talk about interaction of contrasting air mass. Contrasting air mass. Okay. That should be more than enough. Okay. And if you ask me what are the regions which is known for this bomb cyclones, obviously bomb cyclones are very common in, say, for example, the northern part of Americas and northern part of Europe. Okay. But still, it says the four active regions which are hotspots of bomb cyclone. Northwestern part of Pacific. Okay. So northwestern part of Pacific is more like the eastern extension of Siberian region. Am I right? The Verkhoyansk mountain, the cold pole of the world, etc. The northern regions of Atlantic Ocean. When I say northern regions of Atlantic Ocean, it includes both, say for example, almost the Laurentian plateaus, the Canadian regions, the US regions, am I right? The coastal US, that means the Atlantic coastline of US, and it also includes the European regions. Okay. South Pacific. South Pacific, it is not so common. Only thing is in Argentina, slightly, right? For example, sorry, when I talk about Southwest Pacific. Southwest Pacific is more like what? The Australian side. It is not so strong. Okay. And again, the southern regions of Atlantic Ocean, it also includes what? Argentina. Okay. But whatever be the case, right? When I talk about one region where it is very, very intense, if you ask me, it is the northern regions of Atlantic Ocean and Siberian region. Okay. It is very, very, right? Bomb cyclones are very, very common. Okay. Right. And I've added some additional informations where if you want you can make use of it. Okay, sometimes bomb cyclones behave like conventional winter storms. That's where I have just brought in this blizzards. Okay, but sometimes they produce heavy flooding, blizzard like condition. What is blizzard? Extreme snowfall, very extreme cold winds you'll be experiencing. Okay, and wind speed comparable to category 1 hurricane. Right, hurricane in the sense cyclones, American parlance or North Atlantic Ocean parlance, they have this five category of cyclones. They don't use this term called as cyclones, they use this term called as hurricanes. Okay. The danger lies in the fact that bomb cyclones can take people by surprise, of course. Hence, awareness about the bomb cyclone is primary. This and all. Conclusive statement if examiner asks for. This particular question, do not need this explanation, but still I'm just giving you. If at all, if examiner asks about the opinion, you can always say, right? Okay, right, my difference, right? Now, takeaway points. What is a bomb cyclone? Takeaway points. This point is very, very important. Only one line. Suddenly, if the pressure drops more than 24 millibars in 24 hours, that is the condition of bomb cyclone. Okay, right. That is bomb cyclone, right? And when I talk about bomb cyclone, normally bomb cyclones results in blizzard-like condition, heavy snowfall, right? Right, strong winds, etc. And they are very common during winter storms. Okay, essential conditions needed, as I said, right? Rapid rise of air mass, frontogenesis process, right? Contrasting air mass convergence. Okay, that should be more than enough. Okay, right, right, my friends. And a piece of information. So June 22nd, a separate batch is starting. A comprehensive batch for UPSC Civil Service Examination 2024 is starting, where almost largely the 100% of the syllabus will be completed, right? And it will be a 1 year exclusive batch, and the medium of instruction will be in English. So this batch starts on June 22nd. Okay, right. Especially for the students who are using this Unacademy platform. Okay, right, my friends. Okay. Now, taking the second question. What do you understand by Western disturbance? What do you understand by Western disturbance? Mention its impact on Indian climate. Again, why I have taken this Western disturbance, I'll tell you. Because see, Western disturbance and all, it is a year-on-year phenomenon. Every year, winters, I'll be having this Western disturbance taking place. But still, very recently, we have come across a phenomena called as Karakoram anomaly, right? What is this Karakoram anomaly? When every, say, for example, glaciers of the world, when somewhere it was experiencing the retreat, right, or shrinking of glacier, we call them as a glacial retreat. Okay. See, what is this glacial retreat? When now slowly, steadily, you will be finding that the size of the glacier will start diminishing. That's what you call them as what glacial retreat. But on the other hand, we find that the Karakoram glaciers or the size of the glaciers are increasing. One of the reason for, say, for example, the glacial accumulation, what Karakoram ranges. See, why Karakoram range the glaciers are accumulating? Two reasons are there. Number one, for accumulation, you need a source. Source should be precipitation. And what brings the snowfall in Karakoram range mostly, it is western disturbance. See, monsoon also reaches Karakoram ranges, but by the time it reaches the Karakoram range, imagine by difference, monsoon wind has to claim Shivalik, then again descend. Again, it has to claim Himachal range. Again, it has to descend. Again, it has to claim what? Say, for example, the Himadri or Great Himalayas. Again, it has to descend. Again, say, for example, it has to rise Zaskar range. Again, it has to descend. Then Ladakh range. Then again, it has to descend. Then only it will be reaching what? Karakoram. See how many mountains are there? Shivalik is there. Himachal ranges, that is Pir Panjal and Dauladhar is there. Then the Great Himalayas is there. Then Zaskar mountains are there. Then Ladakh is there. Then only I have Karakoram. So by the time this monsoonal wind reaches this Karakoram range, it becomes dry. See, it brings some moisture, very minimal moisture. But if you ask me, Karakoram range, Ladakh regions, etc., which is the major source of precipitation, is western disturbance. Okay, so that's the reason I have just taken a one question on western disturbance. So here, what the question says, what do you understand by western disturbance and mention its impact on Indian climate? So I have to divide this question into two segments. Okay, earlier one, the question itself was divided into two. Now here you have to divide part one of the question. Examiner is asking you to explain or tell him what exactly you understand by western disturbance. Very simple, straightforward question. Number two, mention its impact on Indian climate. Okay. So first we'll define it. Okay. First we'll define it. So western disturbance is an extra tropical storm, right? Even if you say extra tropical cyclone, I don't mind. Even if you say extra tropical cyclone. See, but see, if you ask me, is this word usage of the word called as cyclone is accepted? If you ask me, why not? Nothing wrong with it, because any low pressure you can always use this word called as cyclones. Okay. And one more thing, western disturbance is actually caused by jet streams. It is caused by jet streams, right? Jet streams. Because every surface wind, I'll be having an upper air tropopause wind also I'll be having, compensating wind I'll be having. Okay. We do have jet streams which is flowing at the tropopause level. Okay. And you know, jet streams are geostrophic wind and they encircle the entire earth. And jet streams, permanent jet streams are generally they flow from what? West to east. That's the reason jet streams are sometimes also referred as what? Westerly. Okay. Even if you say extratropical storm or cyclone, nothing wrong in it. Because any low pressure, anything which brings moisture, you can call it as a cyclone. You can call it as a depression, nothing wrong in it. Okay. So it is more like a wind that comes from what? The Mediterranean region. Okay. So western disturbance is an extratropical storm originating in the Mediterranean region that brings sudden winter rain to the northern parts of India. Right? To be very precise, it is northwestern, right? Northwestern parts of India. Okay, right. Indian subcontinent. So it is a non-monsoonal precipitation pattern driven by the westerlies. That's what I said. Sometimes also referred as what? Westerly. Okay. So, or I'll give you one more easy definition also. So this western disturbance is nothing but winter precipitation in India. This winter precipitation in India is very popularly called as what? Western disturbance. Okay. Why it is called as western disturbance? Because this moisture laden wind is coming from what? West. Okay. So the moisture in these storms usually originate over Mediterranean Sea. So which part of India Mediterranean region is located? It is located towards the western side of India. Am I right? The Mediterranean Sea, not only Mediterranean Sea, Caspian Sea, and marginally from what? Black Sea also. So whichever water bodies which is there in the western side of India. Okay, this extratropical storms are a global phenomenon. I said right, geostrophic wind which encircles the entire Earth, right? With moistures usually carried in the upper atmosphere, tropopause level, right? So unlike the tropical counterpart where moisture is carried by the lower atmosphere, that is surface wind, right? In case of Indian subcontinent, moisture is sometimes shed as rain when the storm system encounters Himalayas. Okay, because see, keywords are very important. Unless and until examiner asks you about the explanation or explaining the process, explanation of the process takes your words away. Of course, what I am just giving you. Again, if you ask me, should I write everything in the answer? Not at all. Only the keywords you take it. Okay. I can write, simply I can write western disturbance is the winter precipitation in India, right? And the moisture is carried by the jet stream, right? So how exactly it goes for condensation when the jet stream, moisture laden wind carried by the jet stream, when it encounters the cold wind coming from the Himalayas, it goes for condensation and it can goes for what? Precipitation. Okay, right. Now, I already said which part of India experienced western disturbance. If you ask me, the northwestern part of India. Northwestern part of India. Say, for example, Jammu and Kashmir, Ladakh, Himachal Pradesh, Uttarakhand, right? Punjab, Haryana, Delhi, Rajasthan, parts of Madhya Pradesh, larger part of, say, for example, Uttar Pradesh. All these places they experience what? This winter precipitation, northwestern part of India. Or I can also say whichever part of India experience true winter, right? Winter par excellence. That part of India experience what? Winter precipitation. Okay, right. So what is western disturbance? Where exactly the moisture comes from? Which part of India receives western disturbance? That much we have taken it. Okay. Now positive impact. Precipitation during the months of winter. Positive impact. See here, again, I have just given you some of the points. Somewhere 5 to 10 percentage of precipitation in India is brought by western disturbance. See, for example, nearly 70 to 75 percentage of precipitation, annual precipitation is brought by southwest monsoon. Okay, southwest monsoon. The remaining only the Coromandel coastal parts of Tamil Nadu, right? Almost the larger part of Tamil Nadu and parts of Andhra Pradesh receives precipitation from what? Northeastern monsoon. Okay. And western disturbance almost happens to be, say, for example, another third very important source of precipitation in India. Very mild, but still very effective. Apart from that, we do have local showers. Goes by many names, am I right? mango showers, tea showers, Kal Baisakhi, cherry blossom showers, plenty of names it goes for. Am I right? Bardoli Chira, plenty of local showers we have, right? And we do have precipitation during what? The cyclonic surge. Say, for example, Biparjoy, somewhere, say, for example, likely to have its landfall in what? Gujarat. So that will bring precipitation. All right. Even cyclonic precipitation will be having it. Okay. So 5 to 10% is a considerable precipitation. Right. Fine, my dear friends. This is one. Number two, they are responsible for the majority of rainfall in northwestern part of India. Already I said. During the winter and pre-monsoonal seasons. Okay. Right. So cloudy skies, warmer night temperature, and unusual rains are all signs of western disturbance. That's okay. That may not be a positive impact. Okay. Now, very, very important, my dear friends. They are very, very important for Rabi crops. See, Rabi crops are winter crops. Rabi crops needs cold condition or cooler condition. Why should I use this word called as cold? Right? Less temperature. And very importantly, that water requirement for Rabi crop is very less. But that doesn't mean that water requirement is not at all needed. Am I right? So, plays a very important role. Wheat, mustard, and all. This, say, for example, western disturbance brings the timely precipitation, right? So, wheat is one of the most important crops in India as it contributes to the country's food security. The role of precipitation from western disturbance in the growth of wheat and other rabi crops cannot be overstated. And let me also tell you, this winter precipitation will also prevent the frosting of the plants. Okay. See, whenever I have precipitation, that to rainfall during the winters, normally we have a perception that it will be reducing the temperature. No, water is a moderator. Whenever I have a rainfall during the peak winters, the temperature will slightly rise. Whenever I have a precipitation during the peak summers, the temperature will reduce. So water is a moderator. Okay, right. What can be the negative impact? I'll tell you. Sometimes, right? I can talk about negative impact. Strong western disturbance, on the other hand, carry a lot of rain, which can cause damages. Okay, landslide, flood, avalanches, etc. If it is very strong. Okay. Whereas when I talk about poor western disturbance, on the other hand, it can result in what? Crop failure. Okay. See, any mechanism you take it, right? Deficit will also create losses. Surplus will also create losses. Even southwest monsoon, I can take it. Deficit will result in drought. Surplus will result in flood and landslide. Okay, right. Fine, my difference. So, to be very precise, what is western disturbance? Define it. Winter precipitation in India. Which region gets benefited? What exactly carries the source of moisture? What is the time when exactly you receive it? Explain it. Then, impact, right? We'll talk about the positive impacts, right? And of course, negative impact also. If you want to add it, you can add it, right? Okay. Right, my friends. Now, question number three. Again, this I am anticipating. I'm anticipating because monsoon, right? Monsoon has started June 8th. IMD officially said, what is a, see the kind of a coincidence. June 8th, the two phenomena has taken place. One, Indian Meteorological Department officially announced that monsoon has entered India. Same date, right? National, say for example, Organization of Atmosphere and Administration, like what we have for IMD. Say for example, USA have this NOAA, right? So this NOAA has declared that US Department of, say for example, almost their weather department, right? Meteorological department declared that El Nino, say for example, has finally arrived. So June 8th, two phenomena has taken place. Monsoon has officially entered India, and according to, say for example, USA has declared officially the El Nino has arrived. Okay. Now, of course, we have to wait and watch that how exactly this El Nino is going to impact this southwest monsoon. Okay, but whatever be the case. Now, if El Nino would have not been there, assume that till now we had La Nina. Till now we have La Nina. And one more thing, El Nino normally is not associated with cloud burst. But who knows? Weather mechanism is something which nobody understands in totality. Am I right? By the time you come to a conclusion, weather will say, no, no, I am something different. Okay. Whatever be the case. In that way, I am not very pretty sure that whether cloudburst may happen this year or not. But every year, right, we are seeing the occasions of what cloudburst. Only thing is that question is, what is cloudburst, right? And how does it differ from normal rainfall? Also analyze the reasons for frequent occurrence of cloudburst in India in the recent years. See, so there are two explicit questions. Question number one and question number two. Question number one, I should talk about what is cloudburst and how does it differ from the normal rainfall is question number one. Question number two, explicitly it is given. Also analyze the reasons for frequent occurrence of cloudburst in India in recent years. Right. Now, when I take this question number one, within this question number one, again I have two questions. Part A and part B. Right. What is cloudburst? I have to somewhere define it. How does it differ from normal rainfall? I have to somewhere, say for example, differentiate it. Differentiation becomes 1B, right? Definition becomes 1A, right? And say for example, 2, I have to analyze the reason for frequency or frequent occurrence of cloudburst in recent years. Okay. So first I'll go for 1A. I'll define what exactly is cloudburst. Okay. Now, see, let me tell you, there is no universal definition of a cloudburst. There is no universal definition. Okay. As a layman, if you want to understand cloudburst, normally we say heavy precipitation, very heavy precipitation, or how many ever word very you want to add, you can add it. Very, very heavy precipitation, right? Extremely high precipitation. That is layman way of saying what exactly is a cloudburst. Okay. Again, there is no universal definition of what cloudburst, but still, right? IMD, Indian Meteorological Department, has said that whatever event where I have recorded more than 100 millimeters of precipitation in less than 1 hour, or I can also rewrite it as more than 10 centimeters, more than 10 centimeters of precipitation. Both are same, all right? Whichever number you are comfortable, you can take it. More than 10 centimeters of precipitation in 1 hour, right? You call them as what? Cloudburst. For example, when I take, and one more thing, very small area, right? Very heavy precipitation, any intense mechanism you take it, that will be concentrated a very small area. Sometimes you'll feel as though, see how exactly you'll be feeling as though a waterfalls is falling from the cloud. Somebody is pouring water. You go to waterfalls, how exactly the water will be falling, something like that. Okay, right. Now I am defining it. Cloudburst or sudden and extreme rainfall, right? Rainfall event over a limited area in a short span of time. See the words, right? Short span of time. How beautifully it is crafted. Sudden, extreme, am I right? Very limited geographical area in a very short span of time. That's what you call them as a cloudburst. Layman's way of defining. Only thing is that I'm not quantifying it. I'm qualifying it. Okay. Then again, I'm saying there is no universal definition of a cloudburst. However, the Indian Meteorological Department defines cloudburst as any event where 10 millimeters of rainfall have fallen in a span of 1 hour, right? Over a region that is 20 to 30 square kilometer of an area. Am I right? How limited? 20 to 30 kilometers. How short? Less than 1 hour. Am I right? When I talk about extreme, up till what? 100 millimeters. Okay. All words we have just quantified it. Fine. This is what you call them as what? Cloudburst. Very heavy precipitation, which is sudden, happening in a very small geographical location. Okay. Right, my dear friends. Right. The rain is condensed water falling from the cloud, while cloudburst, right. The first part, 1A, we have answered it. What is cloudburst? We have answered it. Now coming to the difference. How does it differ from normal rainfall? Okay, for that I'm just telling you what exactly is a rain. Rain is a condensed water falling from a cloud, while cloudburst is a sudden and heavy rainstorm. All right. It is also rainfall, but a very heavy rainfall. So cloudburst is different from rain only in the amount of rainfall, not in the form. Am I right? Only in the amount. Okay. So rainfall of over 100 millimeter per hour is categorized as cloudburst. Okay. So differentiation also I have just brought. Hence, we can say that cloudburst is natural phenomena, but occurs quite unexpectedly, very abruptly, and rather drenching. Okay. Right. And I've also given you a temporal dimension. In India, in Indian subcontinent, it is generally occurs when a monsoonal cloud drifts northwards from Bay of Bengal or Arabian Sea across the plains, then to Himalayas sometimes bring, right, 75 millimeters per hour. Okay, this statement also you can leave it. You leave it. Okay. One thing, cloudburst. Mostly cloudburst is categorized by a type of cloud called as cumulonimbus cloud. Okay, categorized by cumulonimbus cloud. And cumulonimbus cloud generally formed wherever there is a strong rise of an air mass. The strong rise of an air mass can either be, say for example, almost contributed by a very high temperature and the rapid rise, or even orographic rise. Using a mountain, and if it is climbing, that time also it can result. Okay, right. I have just explained the same. Reason for cloudburst, right? A cloudburst occurs when moisture carrying air moves up a hilly terrain, forming a vertical column of clouds known as cumulonimbus clouds. Such clouds usually cause rain, thunder, lightning, etc. This upward motion of the cloud is also known as orographic lift. See, you call it as an orographic lift only if the rise of an air mass is happening using the slope of a mountain, not every time. Correct? Okay. So these unstable clouds cause an intense rainstorm over a small area after becoming heavy enough and locked in the ridges and valley between the hills. Okay. So cloudburst. So one thing I understand, cloudburst is very common and normal in a hilly region. The energy necessary for the cloud slope, okay, that and all you leave it. Okay. So the moisture is usually provided by low pressure system, right? Over Gangetic plains associated low level, sometimes winds flowing in from the northwest also aid the occurrence of the cloudburst. The many factors that have to come together to make a cloudburst event happen make them highly unlikely. Okay, see, one thing, when I talk about also analyze the reason for frequent occurrence of the cloudburst in the recent years, one point always you can add. What is that point? Right, nobody can object to it. You can say cloudburst, right? One is climate change. Climate change, global warming and all, right? Always you can take it. Apart from that, you can also say Modoki-like situation. Modoki, La Nina, right? These are the ones which will further intensify the cloudburst. See, for example, El Nino condition having a cloudburst is very rare, but La Nina condition having a cloudburst is very common. Okay, right. Right, my dear friends. Okay, right. So question number 3 we have answered. Now moving to question number 4. See, this is one area, tsunami is one area where it is explicitly mentioned in the syllabus, right? But till today, they have not asked a question. Paper 3, they have asked a question. Paper 1, they have not asked a question. Okay. So I always feel that if something is given explicitly in your syllabus, the chances of asking a question in this area is what? Very high. Okay. So that's the reason I have also taken the case of tsunami. Okay. See, normally we say this important geophysical phenomena such as earthquake, tsunami, volcanic activity, cyclones, etc. is also good, right? Whatever, say for example, comes in news, that is normally given more. Obviously, I understand. Whenever examiner is setting a question, always what will be there in his mind, whatever has happened in the recent time, if it is relevant with the syllabus, that is the one normally as a human brain I'll be going for it. Okay. But I should also understand, right? There are few conventional areas where I should not leave any of my preparation. Okay. So tsunami, so far they have not asked a question in paper 1. That's what I believe. Right. So if that is the case, talking about tsunami, right, is also worth. Okay, it is worthy. Just to have a question, do not expect a tsunami to come. Okay, right. Now, my dear friends, what is the question? Tsunami generally do not affect the sailors of the open ocean. That is a statement. That is a fact. Examiner is asking you why. Why exactly tsunami normally? See, tsunami itself, if you ask me what is the meaning of tsunami? Tsunami means harbor waves. It means harbor waves. Okay. Why exactly it is called as harbor waves, if you ask me? Because Tsunami as a wave generally affects only the, say for example, the coastal areas. It affects only the harbor region. See, normally what happens, the Japanese fishermen go inside the sea for fishing. They don't feel anything. By the time they come back to the shore, they have seen that an entire village has been devastated by these waves. Right? So one thing I know, by say for example, taking the clues from the past, tsunami generally affects only the coastal margins. Tsunami affects do not affects the sailor of the open ocean. For that case, I cannot even say, for example, differentiate a tsunami wave and a normal wave in the open ocean. Okay. The question is asking about the same. Why? Why tsunami do not affects the sailor of the open ocean? Okay. Now see, in this particular question, I have given plenty of extra information which is not part of the answer, but still I have given you facts about tsunami. I'll tell you what exactly is a part of the answer, right? Where exactly I'm addressing the question, I'll tell you. Because see, examination, I always feel that you should avoid junk. What is junk, right? Not necessarily my content is wrong. My content can be correct, but this content is not answering the question. That is what we call them as what junk. Junk has to be avoided. We have plenty of junk right here, but only thing is that that is a source of information, right? I'll tell you while reading it, I'll tell you that what I can write it for the examination, what I have just take it as an additional information. Okay, all this paragraphs is additional information. Okay, even mechanism of tsunami is additional information. Okay, only say for example I have answered tsunami here, only this three paragraph is part of my answer, only these three paragraphs. Okay, three or four paragraphs. Okay, right. Now I'm just adding few informations. You know, tsunami is a series of waves caused by earthquakes or undersea volcanic eruptions. Okay, so tsunami is a Japanese word. In Japanese word, tsunami means what? Harbor waves. A tsunami is a series of very long wavelength waves. Right. I'll show you this diagram also. I'll tell you that why exactly these wavelengths are very large. Okay. In water bodies like seas or large lakes caused by a major disturbance above or below the water surface or due to the displacement of large volume of water. For example, 2004 we had one devastating tsunami. All right. And this tsunami was, say, for example, was resulted due to what? Earthquake. Epicenters, Indonesia, right? Sumatra. Volcanic eruption, right? For example, this Krakatoa volcanic blast, 1883, almost 140 years before, we had this Krakatoa volcanic eruption. And let me tell you, this volcanic eruption had Krakatoa again in Indonesia. Krakatoa is a small island in this Sunda Strait, right? One small volcano, small island in Indonesia, it blasted. And my dear friends, this volcano blast has created a sound, and that sound is so powerful, and that sound is so, right, say for example, intense. And the sound has circumnavigated the earth, not once, not twice, four times it has circumnavigated the earth. Recorded history says that humans have not heard a sound which is louder than Krakatoa incident. This is the loudest sound that what humans have recorded in their history. So that particular incident has also created one tsunami, deadliest tsunami, right? Even landslide, my difference. Landslide have caused a tsunami, right? Tsunami caused by collapse of, say for example, again, Anak Krakatoa. Anak Krakatoa means baby of Krakatoa. 2018 it has created one, say for example, tsunami. And even 2022, the beginning of 2022, my dear friends, you would have heard about this, right? Tonga. It's called as Hunga Songa volcano, right? It is there in Tonga. I think Hunga Tonga volcano. So Tonga, there is a volcano, and that volcano, submarine volcanic eruption, also resulted in what? One tsunami. 2022, very mild tsunami we had. Okay, it was not devastating. Okay, so somewhere I'm just telling you some of the incidents where tsunami can be created. Okay, mechanism of tsunami. See, megathrust earthquakes causes a sudden displacement in a seabed, sufficient to cause the sudden rise of a large body of water. All of a sudden, that's what this image shows you, right? Megathrust earthquake. Suddenly, the megathrust earthquakes, if it is lift a considerable portion of the submarine platform, all of a sudden, this water above it will be lifted. Amount of water will be created. Okay. Once the amount of water is created, this amount of water will start moving in all direction. Slowly, steadily, it will start gathering the pace, and it will accelerate and it will reach a maximum speed of somewhere around 800 or 700 kilometer per hour. Imagine. Okay. And finally, it will be reaching the coastal areas. Okay. Right. Fine, my dear friends. So, wherever amount of water is created, this amount of water can always result in what? The formation of tsunami. Right. That's what this statement says. As a subducting plate plunges beneath the less dense plate, that is oceanic crust going below continental crust. That's what they say. Stress built up and locked zone between the plate gives up abruptly, right? Gives way abruptly, and part of the oceanic crust is then upthrusted, resulting in displacement of, right, say, water. And one more thing, you can also read it. You can also read it, right? Later also, somewhere. You can pause it and you can read it. So somewhere I'm just telling you, all this mechanism, my dear friends, directly or indirectly, right? Directly or indirectly, create amount of water. So once the amount of water is created, this amount of water will start moving in a great velocity, right? It will accelerate and it will start moving in a great velocity, and it eventually becomes what? Tsunami. Okay. Now, coming to the question. All this information, what I have given, is not part of question. Right now, I am just coming to the part of question. Okay. In that way, having said that, okay, I'm there in the question as such. See here, my dear friends. When I talk about tsunami, what is very important? The tsunami waves. If you are there in open ocean, already said, the wavelength of tsunami is very great. If you ask me, put it in values, normally they say this is somewhere around, it will be 160 to 200 kilometers wavelength. It means between one crest and crest or a trough and trough, there is a difference of 200 kilometers. But if you ask me what exactly is the height, height is somewhere around only few meters. It can be somewhere around 6 meters, 9 meters approximately. 6 meters means 20 feet. 9 meters means 30 feet. Now you may wonder, what is this? 20 feet, 30 feet is too higher. Say, for example, the height is considerably higher. But how come that is not disturbing? And one more thing, this wave is also traveling at a very high velocity. Somewhere I said, right, 700 to 800 kilometers per hour. Then how come it is not affecting the sailors of open ocean? If you ask me, very simple. See, I should not only consider the height, I should also consider the wavelength. It means, imagine a condition, height is 30 kilometers. Sorry, excuse me, height is 30 feet. Okay, I'll take it as 9 meters only, 9 meters. I'm going for maximum 30 feet. That is okay, 3-story building, right? Very large. But see the gradation. When I talk about, say, for example, this elevated portion and the low-lying region, right? The crest and the trough, right? Trough. The lowest point, you call them as what? Trough. And the elevated point, you call them as what? Crest. I have a difference of somewhere around 80 to 100 kilometers. 30 feet of raise, but see the difference, 80 kilometers. Okay, the most elevated point and the, say, for example, lowest point is separated by a distance of what? 80 kilometers or 100 kilometers. You cannot even feel it. All right. But by the time, say, for example, the tsunami waves reaches the coastline, the wavelength decreases and the wave height increases. Right? See the difference. Open ocean, wavelength is high, wave height is less. When I talk about, say, for example, the coastal area, wave height is more, wavelength is decreased. If you ask me why exactly the transition takes place, the transition takes place because of the shallowness of the coastline. It is all because of the shallow coast. So the fast moving wave, when it encounters the land, it will start rising. Okay. If that is the idea, my dear friends, if that is the idea, now I'll read the part of my answer. Okay. So tsunami generally do not affect the sailors of the open ocean. Why? This is what the answer is. Okay. So somewhere I'm just telling you, where the ocean is deep, tsunami can travel unnoticed on the surface at the speed of up to 800 kilometer per hour, crossing an ocean in a day or less. Okay. So scientists are able to calculate the arrival time of tsunami in different parts of the world based on their knowledge. Okay, water depth, distance. Of course, we have the tsunami early warning systems also. Okay, now here, tsunami can be less than a foot also. It can be less than a foot also, right? It can be somewhere around 30 centimeters also in height. on the surface, where in open ocean. Okay, which is why they are not noticed by sailor. I'm not saying every time it is 30 centimeters. Okay, slightest rise, even 30 centimeters. Okay, it can be a raise. Okay, so 1 feet is nothing, am I right? But the powerful shock waves of energy travels rapidly through the ocean as fast as a commercial jet. Okay, once a tsunami reaches the shallow waters, nears the coast, it slows down. The velocity will come down, right? The top of the waves moves faster than the bottom, causing the sea to rise dramatically. Okay. Now see my difference. Geological features such as reef, bay, river entrance, undersea formations may, right, dissipate the energy. In somewhere, it acts as a barrier. In some places, tsunami may cause the sea to rise vertically, right? Only a few inches or a feet. In other places, tsunami have been known to surge vertically. See, right? It can rise up to what? 30 meters. 30-meter means 100 feet. Okay, right? By various, say for example, reasons are there. Okay, and now I can see the difference. Open ocean, even if I just take the tallest of the one, say for example 9 meters, smallest of the one, it is only 1 feet. But see, when it strikes the coast, it can rise up to what? 100 feet. See the difference. Okay. So most tsunamis cause the sea to rise not more than 10 feet. Okay. But when I talk about, say, for example, the Indian Ocean tsunami of December 26th, 2004 caused a wave height of up to what? 30 feet. Okay. In some places, according to the news report, in another places, witnessed described of a rapid surging of the ocean. Okay. A tsunami wave with an amplitude of a meter or so that can go as fast as 700 kilometers per hour in open ocean, right? A speed of an aeroplane. That's what the previous paragraph said. When a boat is at the depth of sea, a tsunami just seems like a normal wave which has no effects on the boat itself, right? It is only when the tsunami reaches the shallow waters near the coast, it gets a destructive impact. The wave sort of piles up and gains the height. The boats near the coast will then be carried inland, right, like anything else on shore. Okay, so if you ask me why exactly tsunami do not affect the sailors of the open ocean, because open ocean, the wave height is less, wave length is more, right? It is very hard to notice the tsunami as a wave, right? But the same tsunami wave, when it strikes the coast, it becomes more gigantic. Wave height increases, wave length decreases. It becomes destructive in nature. Okay, so that is the part of the answer. Right, my dear friend. So 4 questions we have taken, we have discussed. Okay, now coming to question number 5. Question number 5. Again, this term, word, again a catchy phrase, sometimes becoming popular. So again, so there is a chance that we may discuss about the same. That's the reason I have just taken it. What do you understand by new normal in weather? Okay, that is one question. The second question, with examples, discuss about some of the new normal weather phenomena on the recent past. The recent past, we have to take it and we have to discuss it. Okay, so what do you understand by new normal in weather? With examples, discuss about some of the new normal weather phenomena of the recent past. Okay, so 2 parts. So first, I'll try to say what exactly is this new normal in weather. Okay, new normal in weather. Okay. Now, see this word new normal. First, I'll try to understand what exactly is new normal, and I'll put it for weather. See, for example, now we do not wear this mask anymore, right? But last year, same time, or 2 years before, same time, same month, if I just take it, wearing a mask is very common. Okay, wearing a mask. Somewhere, if you see a person without a mask, somewhere he or she, say for example, appears abnormal. Okay. But if you ask me, till 2020, 2020, early parts of 2020, before, say for example, February or March 2020, if somebody is wearing a mask, okay, whoever was wearing a mask, it was looking, say for example, very much abnormal to us. But now, or say for example, last to last year and all, what happens? A person who's not wearing a mask was looking somewhere abnormal to us. So what is this new normal if you ask me? What was not normal earlier eventually becoming a normal condition. You call them as what? New normal. That's what we used to say. What was not normal and abnormal eventually becoming, say, for example, normal, right? You call them as what? New normal, right? What was abnormal and not normal becoming normal is called as new normal. Okay, that's what I have just explained it. Only thing is that I have to somewhere explain this new normal in terms of weather mechanism, right? So, for example, abnormal weather phenomena eventually becoming normal is referred as new normal in weather, right? I'll tell you, I'll put it in this way. Landslide is it's a disaster. Am I right? Landslide is a disaster. Cloudburst is a disaster. Cyclone is a disaster, right? Until, say, for example, before the COVID, near about 6 years, near about 6 years, continuously Kerala was experiencing landslide. Continuously. Now, say for example, this was one situation where, see, for example, landslide every monsoon, not necessarily that you will be having a landslide to the right degree of disaster, it will be happening. Am I right? Recently, also, we had a, say, for example, right, film called as 2018, the Malayalam film. Okay, whatever it is the case, it was talking about one, say, for example, this landslide and flooding in Kerala. Okay, what I'm just trying to say, Kerala flood and landslide has become what? Repeated every monsoon. Say, for example, it has become right a normal weather phenomenon. Earlier, it was very abnormal, right? But at one instance, landslide, having a landslide during the time of monsoon itself became what? Common, normal. So we'll say, okay, this monsoon we are going to result means it is going to result in what? Landslide. You are expecting it comes. Increased number of cyclones. Again, I understand it is not normal. But nowadays, say for example, experiencing increased number of cyclones itself has become what? Normal. Right? Experiencing, say for example, very interestingly, monsoon season in India is between this mid-June to mid-September. Am I right? Mid-June to mid-September. Okay. Normally, what happens? 1 month we'll be experiencing, for example, 1 month same region. So, for example, if I take Maharashtra, 1 month I'll be experiencing flood, another month drought, another month flood. See the beauty. Within the span of 3 months, 1 month flood, 1 month drought, 1 month flood. Again, say for example, this has become what? New normal. The coexistence of same month, one part of India experienced drought condition, another part of India experienced flood condition, extreme conditions, right? Assam floods, every year I have Assam flood. That has become what? Something normal nowadays. Okay, so that's the reason I said, right? Abnormal weather phenomena, right, eventually becoming normal is referred as new normal in weather. Okay, so what do you understand by new normal? I have just given it. But see, one justification we have to do it. Since they have explicitly mentioned as two questions. They have mentioned it as two questions. So considerable word limit has to be given for new normal. Okay. So I have to write more words about new normal. See, for example, of course, I understand. You may ask, right? Apart from definition, what is there to talk about new normal? Directly, I'll go say, for example, with examples, discuss about the new normal weather phenomenon in the recent past, right? Something like that 10 percentage of word limit I'll be devoting it. 90 percentage of word limit I'll be devoting it. No, that should not be done. Okay. Minimum I can go for 30-70. See, going for 50-50 is okay, but here this question rationally says at least I can go for 30-70. 30 percentage of word limit I can put it for explaining what is new normal in weather mechanism. Then I can 70 percentage. If you can go for 50-50, it is well and good. Nothing wrong on it. Okay. But at least I can do one. Okay. Right. Right, my friends. Now, adding it. In recently released Indian Meteorological Department, recently in the sense even contemporary, say for example, committee, commissions, report and all, I am taking it because I have just taken the date of 2019. Okay. Confirms that extreme weather event has become more, right, become par for the course in the, say for example, for the course in the country. The Statement of Climate of India 2019 notes that excessive heat, cold, and rainfall, right, have almost, say, for example, resulted in the casualty of 1,562 people during that year, right? And somewhere they say the mean temperature, right, last year in the sense, right, it was somewhere around 0.36 temperature or degree centigrade. above the normal, while the country also recorded excessive rain during both the southwest and northeastern monsoon. Okay. UN International Strategy for Disaster Reduction clearly, say for example, depicts the increase in the frequency of extreme weather events, right? Not following the graph as such. Okay. You can also give the examples of Kerala floods, Kerala landslides, am I right? Increased number of cyclones, etc., as explaining what new normal weather. Now, they say, with examples discuss about some of the new normal weather phenomena of the recent past. Okay, see, recent past, how recent you have to justify it. Okay, now one I can say, right, increased number of cyclones, right? Exactly telling the number and all, it is not needed, right? But I have just taken the number. All of a sudden, the number of cyclones, right, has increased. For example, in that way, if you ask me, uh, Indian Meteorological Department, right? Somewhere in Indian Ocean region, my dear friends, last year, calendar year, we have recorded somewhere around 12 deep depressions and cyclones. Among them, if you ask me what exactly is the exact right count, it is 7 plus 3 plus 2. 7 are deep depression, 3 are cyclones, 2 are severe cyclonic storms. Okay, right. Increase year on year, we have started, say, for example, we experienced what? Increased number of cyclones. Okay. Number of heat waves. One side cyclones also, say, for example, it has increased. Heat waves. The recent development, Indian Meteorological Department has warned this year that summer will be very hot. Okay. I'm just talking about the summers, what we had very recently. Okay. Right. And this was the second consecutive year that the IMD has forecasted a hotter than the usual summers, right? So March to May of 2022. So last year, India witnessed an unprecedented heat waves, right? And one more thing, uh, some of the facts, if you're not very sure, without putting a year, right, without mentioning it by numbers, always you can say, right, last year, until recently, right, very recently, qualitative words you can use it. Okay, monsoon variation. Last year, say for example, Kerala, right? Kerala, the southern Karnataka, Gujarat were heavily deficient till July. Okay, so just kindly excuse me for a minute, I'll be back. Right, my friends. Now, somewhere I'm just talking about this monsoonal variations. So, monsoonal variations can also be, say, for example, taken as an example. And repeated floods, right? Repeated floods, right? If you have a data, you can give the data. Otherwise, simply you can say the number of incident of floods in the recent past has increased. One or two examples of the state of the flood also you can give it. Okay. And what else, say, for example, you can add it, I'll tell you, right? Extreme weather phenomena, right? You can also add it. Say, for example, once I said flood, you can write the coexistence, right? The coexistence. The coexistence of flood and drought put together, right? This can also be added, right? Apart from that, if you can add, what else you can add? Increased number of cloud burst incident. Okay. The increased number of cloud burst incident you can add it. Am I right? And even say, for example, unprecedented hailstorms also you can add it. Hailstorms, right? And see, I'll tell you, snowfall in the deserts of Saudi Arabia, very uncommon. Am I right? Very, very uncommon. Even say, for example, places like Kodaikanal and Ooty, they have experienced what? Say, for example, snowfall. These are uncommon, right? This is what we start calling it as what? The extreme weather phenomena. The extreme weather phenomena itself becoming common, you call them as what? New normal. Okay. So this is one kind of an open-ended questions. Okay. So if it is asked in 10 marker, right? If at all it is asked for 10 markers, you just don't explain heat waves. Simply you say the incident of heat waves in the recent past has increased, right? There is a rapid variation in the monsoonal precipitation and distribution, correct? Increased number of flood events in the recent past, one or two example you give it. Am I right? Increased events of cloud burst, right? Coexistence of flood and drought, right? And extreme weather events like snowfall in South Arabia, if the question is right, not pertaining only to India, I can also go for examples outside India. Okay. So what is new normal in weather phenomena? With examples also we have explained it. Okay. Right, my dear friends. So moving to another question, a conventional question, very conventional question. Already this question was once asked in the UPSC past. And I would have shown you the very first class when we have taken this answer writing practice, I told you. There are instances where the same question with small alteration, right? Or the similar questions are asked. If that is the case, always it is, say, for example, what is this? Knowing is always better. Okay. What is temperature inversion? What are the causes of temperature inversion? Direct question. Okay. So what is temperature inversion? See, normally when I talk about troposphere, the weather layer of the earth, the most important property of troposphere, we call them as what? Normal lapse rate. Normal lapse rate. So what is this normal lapse rate if you ask me? You increase the height. You increase the height in troposphere, generally the temperature will decrease. That's the reason hill stations are colder, right? Why hill stations are colder? Because it is of normal lapse rate. Because I know that the atmosphere generally heats up from the bottom. Okay, right? It occurs from the bottom. Okay. So having said that, troposphere, you increase the height, temperature should decrease. But when talk about, say, for example, temperature inversion. Temperature inversion is a situation where you increase the height or altitude where temperature will also increase. Okay, a small layer. Remember? So this layer is what we call them as what? Temperature inversion layer. Okay. All other places you see, with increasing height, what happens to the temperature? Temperature is decreasing. But this one small layer, right? Temperature will also increase with increasing height, right? So wherever normal lapse rate you do not experience normal lapse rate, right? Instead of decrease in temperature, if the temperature is increasing, that we call them as what? Temperature inversion. Okay. So having said this, my friends, having said this, now I'll just tell you that what exactly is temperature inversion, right? Normally, the temperature decreases with increase in elevation. It is called as normal lapse rate. At times, the situation is reversed and normal lapse rate is inverted. It is called as inversion of temperature. So inversion is usually of short duration, but quite common, right? It is not long-lived. Okay. Now comes the question, right? A long winter night with clear skies and still air is the ideal situation for inversion. The heat of the day is radiated. That is also not needed. Okay. Heat of the day is radiated off during the night, and by the early morning hours, the earth is colder than the above air. Over the polar areas, temperature inversion, right, is normal throughout the year, my dear friends. Okay, so if you ask me when exactly temperature inversion is very common, simple, I'll put it this way, right? I should have a cold air mass near the surface, and above this cold air mass, I should have a warm air mass. Okay, warm air mass above the surface. Okay. If that is the case, my dear friends, somewhere this condition itself, I'll put it this way, right? When I take the temperature inversion, I have a warm air mass here. Comparatively, I have a cold air mass here. So this itself gives you an idea when temperature inversion is very common, ground condition should be cold. Okay. Above the cold air mass, warm air mass should be there. Am I right? I'll put this way, right? Ground condition if I have a cold air mass. Okay. Above the ground condition, if I have the warm air mass, you increase the height, temperature will also increase. Now, this gives you a clue. Where all and when all I'll be having cold ground condition. Number one, polar region. Throughout the year, cold condition. That's the reason they say over polar areas, temperature inversion is normal throughout the year, right? That is region. But if you ask me season, which season, say for example, temperature inversion is common? Again, I know which season cold condition is very common. Winter. Okay. If that is the case, temperature inversion should be common in what? Winter. That's what it says, right? Long winter night with clear skies. Why clear sky? Because if I have cloud during the night time, cloud will not allow the, say for example, this heat to radiate. It will not allow it to escape. Okay. So what happens? The heat will be somewhere remaining near the surface itself. That's the reason normally if you have a cloudy night, interestingly, cloudy night will be warmer compared to the cloudless nights. That's the reason when cloud is there during the night time, even dew and frost will not be formed even during winters. Okay. So only cloudless night you will be having cold condition. That's the reason they say long winter night with clear skies. Okay. Right, my friends. Right. Now, having talking about temperature inversion. Now, okay. So surface inversion promotes stability. That and all you leave it. Right. Now here itself I have just given where all and when all I'll be having it. Okay. Now specifically I'm taking types of inversion, temperature inversion, when and where I'll be having frontal temperature inversion. You remember, right? I was talking about when I started the very first question, bomb cyclone. I was talking about this. Say, for example, I was talking about this. Okay, maybe I'll take a better tool. Okay, see here. I'll put it this way, right? Somewhere around different, say, for example, pressure belts, 90 degree, 90 degree, say, for example, 30 degree, approximately. Then 60 degree, right? 60 degree. 90 degree is the place where I have a high pressure called as polar high. 30 degrees is the pressure belt where I have a subtropical high. Very popularly, this latitude, we call them as what? Horse latitude. And 60 degrees is the place where I have a low pressure called as subpolar low. Now, here, my dear friends, this is a place I know. From polar high, I have an extremely cold wind that is emerging, traveling towards what? This low pressure. Okay, extremely low pressure or extremely cold wind. You call them as what? Polar winds. And see, again, say for example, from subtropical I have an extremely warm wind again traveling towards this low pressure. And say for example, this wind we call them as what? Westerly, right? Westerly. We call them as what? Westerly, right? Just to somewhere add more points, I'll call it as warm westerly versus cold polar wind. Okay. These winds are so contrasting in nature that they do not readily mix with each other. Because of the contrasting nature, what happens? They forms a clear-cut boundary between them. This clear-cut boundary, right? More like an air curtain, is what we call them as what? Front. We talked about frontogenesis, right? This is what you call them as what? Front. Front is more like a boundary of an air. Now, what happens? Warm westerly and cold polar winds still they will try to merge. But warm westerlies being less in density, what happens? It has a tendency to climb over this front. Okay. Now, once it claims, if I just take this particular, say for example, region alone, if I take it, what I understand, ground condition, I have cold air mass. Upper air condition, I have warm air mass. If I increase the height, what happens to the temperature? Temperature also increases. That is what you call them as what? Temperature inversion. So, this latitude, very popularly, we call them as what? Mid latitudes, my dear friends. Mid latitudes. This mid latitudes, temperature inversion is very, very common. Okay. Throughout the year, it is very common. That is what you call them as what? Frontal temperature inversion, or you call them as what? Air convergence. Why you call them as air convergence? Because this is a place where two air mass will be converging with each other. Okay. Right. Then, apart from this air convergence, right? If you ask me, what are the other situations? Vertical advection or air drainage, right? Normally, this Air drainage, my difference, it happens along the mountainous region. So mountainous region, what happens? Night time and all, what happens is cold air mass will be draining towards what the valley region. Okay. And during the sunrise, what happens? As and when the sun rises, the sun's rays will be heating up the slope of the mountain first. Only during the noon time it will be heating the valley. So valley region, I'll be having cold air mass. By the time sun comes up, right, sun rises, this slope of the mountain or mountain peaks will become warmer. So valley region, bottom of the mountain is cold, mountain tops will be warm. Again, a temperature inversion. Radiation inversion. This is what we were talking about. What? This, say for example, this winter night, my dear friends. Okay. So winter night, what is very, very, say for example, night. Okay, during the day, sun heats up, that and all you take it, right? Very common during what? Say, for example, winter nights. Okay, so these are some of the situations when you experience what? This temperature inversion. Okay, so what is temperature inversion? When exactly you experience temperature inversion, this much we have taken. Okay, right. So moving forward, it's the only thing I'm not able to see your comments because check. Some of the queries, questions, if you have it, I'll take it from the comments and tomorrow's class also I can answer, if at all, if you have it. Okay, right. Now coming to the next question, again, this segment is very important, I feel. I felt it. That's the reason even my prediction class or the main topics, right, very important topics. Earthquake was one of the topic what we were suggesting. And luckily we had one question on earthquake also, right? The same thing I'm just taking from, say, for example, this clue, because repeated earthquakes for two reasons, right? One, repeated earthquake, the twin earthquake of Turkey and Syria is one, right? Apart from that, mm, now more countries are interested in somewhere, interested in knowing the internal structure of the earth or understanding it better. Am I right? So somewhere, earthquake and interiors of the earth takes a central point, right? So in that way, I'm just connecting, right? Seismology, that is earthquake study, and the Earth's interior, that relevance. And we also know the fact when talk about the Earth's internal structure, what has given us the larger picture, larger idea about the internal structure of the Earth is seismology or earthquake study. Seismology is nothing but what? Study of seismic waves. Study of earthquakes, we call them as what? Seismology. Okay. Right, my friends. Now, having said this, right? Now, seismology, a window to Earth's interior. What is the meaning of this statement, if you ask me? Seismology, a window to Earth's interior, means seismology or study of earthquake waves is the one which has given us a larger idea about the internal structure of the Earth. Okay. Only thing is that we have to justify, we have to understand that how exactly it has done it. Right. The question simply says elaborate. They have given a statement, you have to say elaborate. Okay, how simple. It is all about studying this body wave. See, earthquakes, my dear friends, earthquake study will be studying about the different waves that is produced during an earthquake. Particularly when I talk about this earthquake, during any earthquake, two sets of waves are produced. One you call them as what? Body waves, right? And two you call them as what? Surface waves. You call them as body waves and you call them as what? Surface waves. Okay. Now, when I talk about this body waves, what is this body waves? Body waves, as the name itself suggests, they say, for example, travel, right? Or say, for example, they generally propagate only via the interiors of the earth or the body of the earth. Surface waves will be propagating, traveling only along the surface of the earth as such. Okay. In that way, my dear friends, that way, body wave is the one which has given us a larger idea about Earth's interior. For example, body wave itself, I have two waves. There are two types of body waves. They're called as P wave and S wave. P wave means primary wave, S wave means secondary wave. Okay. Two types of waves are there, primary waves and secondary waves. Why it is called as primary wave? Because among all the waves, the fastest moving wave is what? P wave, primary wave. It travels somewhere around 25,000 kilometers per hour. 25,000 kilometers per hour it travels. Okay. something beyond imagination, am I right? Somewhere it travels at the rate of somewhere around 6 to 7 kilometer per second. Right. This right. By the time I called as a second, it travels 6 to 7 kilometers. Okay. Right. Fine. Now, S wave travels only half the velocity of this P wave. Right. S wave travels somewhere around 3 to 3.5 kilometers per second. And the two, the state of matter, density, all that determines the velocity of a wave. Not that entire Earth's interior they'll be traveling in uniform velocity. No, not at all. If sound waves, P wave is more like a sound wave. I can understand sound wave will travel right at different velocity at different, say for example, medium, atmosphere versus a solid, say for example, iron rod, whatever you take it. Right? I understand solids, sound wave will be traveling more fast, right? Atmosphere least, something like that. Okay, right. Now, the same wave, my difference. Now here, there are two waves. One is P wave and S wave. Now, very important. What is very, very important? This P wave and S wave, the wave propagation and say, for example, this wave property is different. Okay. I have just given you that two waves vibrates perpendicular to the direction of propagation. Okay. Uh, Normally, this P wave, my dear friends, this P wave, we call them as, say, for example, a longitudinal wave. S wave, we call them as what? A transverse wave. And talk about P wave, how exactly this P wave will be traveling if you ask me. What is the wave propagation? P wave, sometimes you call them as what? Compressional wave. S wave, you call them as what? Distortional wave. P wave will be traveling, say for example, to and fro, or say for example, parallel to the wave movement itself. The particles of the medium will be oscillating, vibrating parallel to the wave propagation itself. Okay, P wave. S wave, they'll be propagating perpendicular to the wave movement as such. Okay, so there is a difference. Okay, but concluding idea, very important. Explanation and all mains examination, it's not needed. And very interestingly, the statement what I said, that was the question which was asked in this year preliminary examination. I'll show the question also if it is possible. So one question which was asked in the past, asked this year. Okay. This is the question that was asked. In a seismograph, P waves are recorded earlier than S wave, I know. In P waves, the individual particle vibrates to and fro, that is parallel in the direction of the wave propagation, whereas S wave particles vibrate up and down at the right angle to the direction of the wave propagation, right? One is distortional wave, and another I said it is a compressional wave as such. Okay, now, these are statements, okay? These are facts. Okay, now here, let me tell you, okay, here I can also, yeah. In the wave propagation, it is shown here. Good. How exactly this P wave moves and S wave moves, right? P wave is a compressional wave. S wave is a distortional wave. So one thing I understand, what is very, very important, P wave, given the wave property, P wave can compress a medium, right? It means given the wave property, my dear friends, P wave can travel via solid, liquid, and gas. See, we do not have any gaseous medium. We do not have any gaseous medium. If we have a gaseous medium in Earth's interior, definitely speaking, say for example, P wave would have been, say for example, somewhere would have propagated via that layer also. But we don't have any layer that is made up of gas. Okay. That's the reason I said P wave is more like a sound wave. It is more like a sound wave, longitudinal wave. S wave is more like a distortional wave, transverse wave, like a light wave. So here, what is very, very important here, I'll tell you. P wave, my dear friends, can propagate via all medium. It can propagate via solid, it can propagate via liquid, it can propagate via what? Gaseous medium. But when I talk about S wave, my dear friends, S wave can propagate via only via solid medium. S wave will dissipate in liquid medium because it is a distortional wave. It has, let's say, for example, capacity to change only the shape of the medium. Okay, this is very, very important, right? Very, very important. So, S wave, as I said, cannot propagate via liquid medium. Cannot propagate via liquid medium. whereas P wave can propagate via all medium. So what happens normally whenever earthquake occurs, everywhere S wave is recorded. S wave is recorded. Small correction, it's not P wave. Okay, S wave. Everywhere S wave is recorded. But what happens? I know the fact that I have a liquid outer core. So as and when, say for example, this S wave enters this liquid outer core, what happens? It starts dissipating, right? So nearly half of the other side of the earth do not experience this body wave. They do not experience this body wave, my dear friends. Okay. So the combined geographical location which do not experience this S wave or any body wave, you call them as what? Shadow zone. So the larger presence of shadow zone, nearly 40 percentage of Earth's surface do not experience that shadow zone. That's what somewhere I've explained here. I've explained here. Nearly say, for example, beyond this 105 degree, here diagram it is shown as 103 degree, but right up it is given as 105 degree. Doesn't matter. Okay. So somewhere beyond this 103 degree, either side of it, right, you will not record this S wave. So presence of S-wave shadow zone strongly suggests that there is a liquid layer in Earth's interior. That liquid layer is nothing but what? Outer liquid core. Then you may wonder, then how come we have a shadow zone for P wave? What is a shadow zone? The combined geographical location where a body wave is not recorded, you call them as what? Shadows. Okay. So P wave shadow zone, my dear friends. Why exactly I have a P wave shadow zone? Because I know that P wave can travel via all the layers, can travel via liquid, it can travel via solid, it can travel via gas also. But what I understand, whenever there is a change in the medium, right? What happens? Any wave will go for a slight deflection in the path of its right wave path, right? It will get deflected. That is what we call them as what refraction. The multiple refraction has caused what P wave shadows. So, my dear friends, to conclude, how exactly I should arrange my answer, right? First, I should talk about the body waves. I should talk about P wave and S wave. I should talk about the wave property of P wave and S wave. At least very important, I should say. I'll tell in my answer, I should put it this way. P wave can travel via all state of matter, solid, liquid, and gas. P wave is very similar to a sound wave, whereas S wave propagate only via solid medium, and S wave do not propagate, or you can say S wave dissipates in liquid medium. Okay, then I should talk about shadow zone. Right? What is a shadow zone? I have to define it. The combined geographical location where you do not experience, right? Where you do not experience a body wave, that is called as a shadow zone. So the presence of S wave shadow zone strongly suggests the presence of liquid layer in Earth's interior, whereas the presence of P wave shadow zone strongly suggests, right, the presence of multiple layers in Earth's interior with different density and different state of matter. Okay, right. That is what somewhere I've explained here also. Okay, right, my difference. So P wave and S wave, how exactly they play a very important role, we have to right somewhere we have taken it. Okay. And again, a piece of information, my dear friends, right? As I already said, so June 22nd, altogether a new batch is starting, right? And again, a GS an optional batch for the students of Unacademy platform is also starting, and you can avail the offer, a limited period offer. So before 17th of June, you can avail the offer. A 25% flat discount is given, and you can use the offer code as Sriram's. Okay, right. So make use of this opportunity, right? Now, going to the last question. And again, why exactly this question is important, I'll tell you, because very recently you would have heard about a phenomena called as king tide. And I believe that, say, for example, king tide is also very important. Okay. So one more class, I'll take the case of king tide. But here, I'll make it very simple. Right? I'll take the mechanism of tides. What exactly it says? Explain tidal mechanism, bring out the significance of it. See, what is a tidal mechanism or tide? The periodical rise and fall of sea level once or twice a day, mainly due to the attraction of sun and moon, is called as what? Tide. See, you call them as high tide and you call them as what? Low tide. Sometimes you go to the beach, you find that sea is very close to you, assuming that it is a time of high tide. I go to the same beach after 6 hours and 13 minutes or somewhere around 6 hours. I find that sea will be very, very far away from me, right? I assume that it is a low tide. So every day what happens? The level of the sea will be rising and it will be falling. That's the reason we use the term called as mean sea level. See, if water can almost remain in the same level, there is no need to use the word called as mean. Am I right? So use this word called as mean sea level. Correct. Now, why exactly tide is created? Very simple. Already we know, right? Tide is created by moon's gravitational attraction, sun's gravitational attraction, and of course, the centrifugal force influenced by them. Okay. Or I can simply say the periodical rise and fall of the sea level due to the gravitational attraction of moon and sun is called as tide. So mechanism, when I talk about mechanism, my dear friends, how exactly a tidal bulge is created? Somewhere I can say that, right? Whenever the moon or sun comes above a particular place, the water will be pulled towards it. Okay. The gravitational attraction of moon will be pulling. And let me tell you, it is 2 is to 1. Moon versus sun, if I just take it, tide created by lunar, or say for example the lunar force or the moon, is more effective than that of the solar tide. See, when sun comes above a particular place also, the level of the water will rise. When the moon comes above a particular place also, the level of the water will rise. But given the moon's proximity, given the fact that moon is very close to you, the rate at which, or the level to what, say for example, the water is being uplifted will be more. That's the reason lunar tide is more effective, more noticeable, right, than the solar tide. Okay, right. Now tidal mechanism, when, right, when exactly a tide will be created? Whenever moon or sun comes above a particular place, a tide will be created. When moon or sun is moving, the tide will also. And my dear friends, what is very practical is a combination of tides, right? For example, if that is the case, I can also differentiate between neap tide versus spring tide. Okay, I can take the other way around. Spring tide versus neap tide. What is the spring tide? Spring tide is the highest tide what I can have. So, for example, if sun, moon, and earth comes in a straight line, where same place, gravitational attraction of moon is also happening, and say for example, gravitational attraction or the attraction of sun is also happening. Am I right? So moon's gravitational attraction will also lift the water. Same place, sun's gravitational water will also lift the water. That is the place where I'll be having what? Very high tide. Okay. The tide we call them as what? Spring tide. Okay. So on the other hand, even if moon is placed here, my dear friends, if moon is placed here, then also I can have it. For example, I just take this situation. This is a place where centrifugal effectivity of moon will cause a high tide, and say for example, sorry, the gravitational attraction of moon will cause a high tide, and centrifugal effectivity of sun will create one high tide. Okay. Whatever it is the case, whenever the sun, moon, and earth comes in a straight line, I'll be experiencing what? Spring tide. Okay, this is moon. Okay, so when exactly sun, earth, and say for example moon will be coming in a straight line, if you ask me, either it will be on, say for example, new moon day, or it will be on a full moon day. Correct. Whereas the first quarter and the third quarter I'll be experiencing what? Neap tide. Okay, right, everything is fine. So tidal mechanism, somewhere I can explain it. Now here it also says bring out the significance of a tide. It can be multi-dimensional. One, navigation. Say, for example, when I talk about navigation, very important, because whenever the water level is rising, during the high tide, the water will start moving towards what? The coastal areas. Particularly when I talk about, say, for example, the riverine mouth, etc. Right? During the low tide, this water will be moving back. So what happens? It normally results in what? The process of desiltation. Particularly when I talk about port, my dear friends, you would have heard about something called as tidal port. Even Kandla port in India, Kolkata port. Kolkata port is not located in what, say, for example, the coastal. It's not located in the coastline. Kolkata port is located, right, well within, say, for example, far away from the coastline. It is located along the Hooghly River, right? Only during the high tide, when the level of the water rises, the ships can enter what? Kolkata port. So it helps in navigation. It helps in desiltation, fishing, right? Because see, high tide also helps in fishing. Many more fishes comes closer to the shore during the high tide, right? That enables, right, more of, say, for example, fishes being catches. Desiltation, as I already said, the movement of the water to and fro of water. Very technically, we call them as what? Ebb current and, say, for example, right, flood current, right? You can call them as what? Ebb tide and flood tide. Okay, or ebb current and flood current. Okay. So the movement of water also results in what? Desiltation. And of course, I understand this tidal rise and fall of the water can also result in what? The electric generation. Am I right? You call them as what? Tidal. Say, for example, energy. Even last class, we are talking about the potential, right? Approximately, I said India has somewhere around 8,000 megawatt of this tidal energy production. Okay. So today's questions, almost everything we talked about the conventional questions. Okay. Conventional question, but still, right, it is very, very important as such. Okay. So tomorrow's class, right, we'll add more of, say, for example, the monsoon kind of a question and other related questions also. We just take it. Okay. So there it brings an end of today's discussion. And tomorrow also we'll take some of the questions for our discussion, right? So, my dear friends, keep pushing your boundaries, keep studying, be motivated, always think positively, avoid negativity, and even say, for example, you can also avoid people who have this negative thought or framework of mind. Okay. So, wishing you all the best.